All right, I know you guys are probably very excited about jumping into the code and start putting this thing together, but first, before we do that, let us go to the drawing board and kind of give an overview of how we're going to set this thing up inside of code without any actual code, just so you have some sort of mental picture of what's going to be going on. So let's start out by drawing our screen. So here we are, very simple screen. And on the screen, what do we have? Well, we have a couple of players that are cruising around, and as they cruise around, they are, of course, leaving a wall behind them. So there's a player there, and then perhaps a player over here, and oh, he's blocking him in. Oh, boy. Simple enough. Now, the question is, how do we go about drawing these walls onto the screen and then keeping track of these walls so that we can then check for a collision with a bike and your own walls or an enemy's walls, okay? Because each time we move into a new location, have we just come into contact with any wall? Because that's the way we've got things set up. Because you don't even want to slam into your own wall. That would be pretty bad. So the way we're going to go about doing this is we are going to divide up the screen into a grid. And then we're going to use each cell in this grid to hold information, basically a wall segment. Okay. Now, there are several different approaches that you can go about putting this together, but this particular grid method works really well. It scales nicely, and it does not require a significant amount of memory in order to do it. So this is going to look something kind of like this. Now, I'm going to redraw this screen. I'm going to divide it up into a grid real quick. Just keep in mind that the resolution is not going to be the same, because in the screen drawn there to the left, that guy's going to have a much denser grid. Of course, I'm not going to draw that out here because it would take forever. So let's, it looks pretty good for grid spacing, so we'll go with something about like this. So right now I'm going to draw in all of my columns real quick. And everybody's comfortable working with arrays by now, so we're going to be working with a two-dimensional array, which is going to make it very easy for accessing any of our cells inside of our grid. Okay, almost there. All right, so basically what are we going to have? Well, we're going to have X running the width of our grid, and we're going to have Y running the height of the grid. So then if we wanted to, at any particular point, the way we're going to have things set up, we can simply access a point by saying, I'm just going to call it walls. We may call it who knows what by the time we get over into code. But, you know, if we wanted to find out what was at walls 3, 2, we're going to set this up where X is going to be represented here, and then Y will be represented here. So if we started out up here at 0, 1, 2, 3, now counting down, since that's going to be Y, we're going to go 0, 1, 2. We're going to be taking a look at this particular cell. Now, everybody knows how to do this. Very easy stuff at this point. Now, what kind of array are we going to put together? What kind of data are we going to be storing in there? What's the data type? Well, we're going to come up with our own custom data type. It's going to be a struct called wall segment, and it's going to contain 3 pieces of information. It's going to contain, is it filled? Basically a bool, true or false. It's going to contain a texture index. And right now, before I move any further, if some of you guys are looking at this going, wait a minute, he's got one called filled, he's got one called texture index. Can we simplify this? Yes, you can simplify it. But now you start getting into some things you need to account for optimization. So that's something to keep in mind. Using filled, simple true or false, that's going to help us keep speed up. Now, we're not focusing on optimization because there are some nifty little things you can do by pulling filled out and representing things with, well, let's say just a simple byte, maybe some masking, and we can do some neat things to keep things nice and fast. But right now we're going to keep this picture as clear as possible so that everyone can follow along. Now, if you see a better approach, I highly recommend employing it. So we're going to have this texture index in there, and we're also going to have a player index. Where the player index is going to be a real player index. Our texture index is going to be a byte, and filled is going to be a bool. Okay? So that is the information that's going to make up the struct, and then we're going to have a two-dimensional array of the struct. So in any one of these cells, in this particular case, we're looking at wall 3, 2, and in wall 3, 2, we can say, hey, are you filled? Yes or no? Well, if the answer is yes, well, what's the texture ID? We can now use that to draw. Well, what are the textures that we're going to be using here? Well, this is the nice thing about not representing everything with a single line. By dividing this up into a grid, we now have the ability to go in there and use custom textures to represent, I don't know, horizontal walls, vertical walls, and our turns. Now, we've got several different turns to account for. Now, let me move back over here to this example right here. Everything's just a straight line, right? In this particular case, I'm saying draw from here to here. Draw from here to here. Right, Logan?
Right. It's
very straight lines.
And the very requirements for the game say that the game's only allowed to turn at 90-degree angles.
That's right.
There's no 45s. There's no smooth curves in turning. You turn at 90-degree angles, which essentially means the movement is up, down, left, or right.
Exactly. But what if I wanted to give that pseudo 3D feel? Where you've got, here's the top of the wall, and it's drawn in such a way that, it feels like, so we've got this little bit of a 3D feel going on to it right here. And then maybe if you turn, it's kind of rounded, right? Something like that. Even though you still turn it at 90 degrees. So now it's been rounded out. Maybe if you turn back the other way.
That way you can graphically stylize the way the wall looks.
Exactly. And of course, and now we could do that with this particular engine that we're setting up. If we were just drawing simple, straight lines, we could not do that. So by using a series of textures to represent a horizontal wall, a vertical wall, and then our different turn variations that we can have, then we could come up with some really nice looking graphics and make this thing look a lot more modernized as opposed to just straight lines from a top 2D perspective. So let's talk for just a second about the textures we're going to need. As I already said, we know for a fact we're going to need a horizontal wall. We know that we're going to need a vertical wall. Now, we can turn, well, we can go, there's so many, we can go left, we can go right, but it depends. Are we going up when we turn left? Are we going up when we turn right? For instance,
I think there's about 8 different combinations.
If we are, there are, which only results in 4 graphics, because we could be going, check this out. What if we were going up? So if we were going up, of course, we would just use this wall right here. So we're going up, but then we turn to the right. So we could come up with a graphic that's got this 90-degree hook in there, like such. But we could have also been going to the left and have turned down. So this one graphic would represent 2 different directions we could have been going and making a turn. You see what I'm saying? That piece would work conveniently for both those conditions. Going up, turning to the right, or going to the left and turning down. Okay, now what if we happen to be going to the right and we turn down? How convenient. So now we could make a curved 90 piece right there. And let me undo that and make it just slightly nicer. There we go. Or what if we were going up and turn to the left? So that piece works conveniently for this. So right now, we've already got 2 different 90-degree hooked pieces that represent a total of 4 different possible turns. So of course, finishing things out, what if we were going down and turn to the left? Well, we'd want something like this. Okay. Now, of course, we could just reuse that one wall up here because it's just a horizontal wall. Now, what happens if we happen to be going to the left and we turn up? Well, we'd want to have a curved piece like this. So we're in a situation where we're going to need 1, 2, 3, 4, 5, 6 different graphics, okay? Well, what if we were simply to put these into an array, and then we could use a texture index to say, all right, well, inside the array, which guide do we need? Let's say that our horizontal pieces were 0. Let's say that index 1 represented our vertical piece, and then starting at 2, we start in the upper left-hand corner, so right here. So 2 would be this guy. 3 would be this guy. So notice how we're working in a clockwise direction. So 4 would be this guy. And finally 5 would be this guy. Okay? So if we were to store that into an array and then simply store the index in the struct, so it's stored in the array of walls. So let's say that in this particular case, at wall 3, 2, that the texture index that we're going to store is going to be a 1. So what would be represented over here? Well, it would be a vertical line. So let's say that up underneath that, position 3, 3, position 3, 4. Now let's say at 3, 5, we were to store, I don't know, position 5, index 5. Well, we'd have this. And then moving over to position 4, you see what I'm saying? And then we could have a horizontal, we could have another horizontal. Then perhaps over here in this position, we stored index 3. So now we're going to hook downwards. And then so down up under, we start, look at that, ta-da! So now we have this wall with nice curvature. We have complete control over what graphic we're going to place into each cell of the grid.
That way we can use the grid cells like one would use a toy train track, where you have a set number of types of pieces, and then multiple of those pieces that can be assembled in any order that you like.
Precisely.
You have a bunch of snap-in style pieces, and these pieces snap into the various grid blocks and allow you to draw any line that you want.
So when we start getting into this, we're going to have a total of 6, 7, 8, 9 graphics. So let's talk about all 9 graphics. So far, you have seen 6 of the graphics just in the graphics required for the different wall segments. Okay, so that leaves 7, 8, 9. We've got 3 more. So what are the other 3? Well, we know a background would be nice. Now, the bike. How are we going to go about handling the bike? What we're going to do is we're going to create 2 textures that are the exact same size that can be laid, one can be laid on top of the other. One is going to contain the bike. So let me draw a quick representation of the bike. Kind of like a Twinkie shape with a little cockpit. There you go. And the other one is going to contain the light emitting source. It's going to look like the light source from the tail of the bike where our laser is going to come from. Okay? Now, why are we doing this? Well, everybody's bike is going to be gray. In our demo of this engine, of course, when you guys put it together, you can come up with some really slick-looking bikes. That's cool. The tails, though, the engine, if you will, needs to be color-coded. It needs to be the color of, well, whatever player you are. Meaning, if you're player 1, you're going to have a red wall. If you're player 2, you might have a green wall, however you want to set it up. But basically, that tail needs to be the same color your wall is going to be. So this tail has been created white so that we can then go in there and modulate it to the color we need to. And player index is going to be what we're going to end up using to do this. And you'll see how we'll put this together when we get over into the coding. It's very straightforward, utilizing techniques you guys already know how to do. But again, when we go to draw each of these different walls out, we'll also be using player index to make sure that the color is the right color for the wall. So not only will we know what texture to draw, we'll know what color to make it based on the player index. We'll also use that player index when drawing our bike to make sure that the tail color is correct. So there's graphic. So 1 texture, 2, 3.
Another thing to point out about the bike and tail textures is to note the way that the textures are laid out in their individual files. The rectangles represent the overall size of the graphic, and you can see in the tail that the tail is drawn at the very bottom of that graphic.
That's right.
These 2 are designed so that when they're laid over one another, it looks like the complete bike.
Exactly.
That way we don't have to have a separate position for the bike and for the tail. We draw the same graphic at the same position, and it's set up to overlay automatically.
Exactly. So as I say, so texture 1, 2, 3, and then 4, 5, 6, 7, 8, 9. So there's the 9 textures that we're going to need. Now, of course, as we begin working our way through the code, as we progress a little bit further along, we're going to start having to deal with origins and making sure things are lined up properly. Keep that in the back of your head when you start putting this together. Obviously, spacing and alignments become very important when working with something like this. You don't want the bike, let me draw a little bike over here, and his quick tail. to be emitting lasers from over here. That might look a little funny. So that's just stuff you need to keep in mind. Okay. So let's see. What else we're going to talk about? Movement. Let's talk for just a second about movement. Obviously, we need some sort of timing system to control our bike moving across the screen. And the player also has the ability to slow the bike down or even bring the bike to a stop by using his right trigger button. So this becomes very important in how we go about handling this, because with 60 frames a second update, okay, what's going to happen if every single update we move the bike one of these cells? So let's pretend the bike's going up, okay, before and we were to update its move position every single update. Before we had a chance to even push the button down, we would have already gone click, 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 boom. And off the screen, way off the screen, okay? So, well, actually, no, not really with the grid size we're going to be using, but you'd already be at the top of the screen. So that's going to be very important with how we manage this. And we're going to manage this with a very simple timing system, something very similar to what we employed back in Precision, where we're going to have a variable that's simply going to be counting down, and when that variable hits 0, it's time for us to move. And just to give a very quick analogy of this as kind of a refresher, we're going to have an hourglass. We can look at it like that. So here's our hourglass. The worst hourglass I've ever seen. And in the hourglass, we have sand. This sand is going to represent the value that is being held in a particular variable. In fact, we'll end up calling that variable time remaining. Let's go ahead and jot this down so that when we come back to it, you guys can be like, oh yeah. So there's time remaining. And what we're looking for is all of the sand to drip its way down here. And once all of the sand has gone out, and what I mean by that is once time remaining hits 0 or goes below 0, it is time for us to move one block, okay, to wherever it is that the player is wanting to move. Simple enough, and at that point, what are we going to do? We're going to take and flip this guy back around, meaning we're going to simply reset time remaining and wait until it gets counted down again before we move again. Simple enough, but we make it a little bit more sophisticated this time around because the player has the ability to slow that bike down. That's the interesting thing. That's where things get a little bit different than when we were dealing with the power-ups in Precision, where that was, boom, here's X amount of time, countdown. When you get done, the cell is dead, the cell's saved, or whatever it may be. Here, though, the sand that is in the hourglass can change. Well, let's think about it. What if I have the amount of sand that you're looking at right now, and it's pouring out? We can predict when we're going to be out of sand and it's time to move the bike. Well, what if somebody was secretly adding more sand in? Well, it's going to take a little bit longer until we move. So what happens is when we hit 0, time remaining needs to be reset. That's when we flip the hourglass and it starts counting again. Well, what do we reset it to? Well, we're going to reset it to the move interval. Okay, now don't get confused. Bear with me. I know this might seem confusing for just a second. All right, so move interval. Now this is interesting. We're going to start out move interval, what is it, Logan, like 0.05, I think?
Right, 0.05 seconds is going to be the move interval.
So 0.05. So this 0.05 is, in essence, going to represent every 0.05 seconds we're going to move the bike. But here's the interesting thing. We can change that move interval. So this move interval represents our default amount of sand that we're going to put in here. So if we said time remaining equals move interval, 0.05, then we know in 0.05 that we're going to, half second, we're going to run out of sand and we're going to move the bike. Simple enough. But as the player presses the right trigger in, what happens? So he presses that right trigger in, he's going to start affecting the move interval. So again, we start adding more sand in there, and the moment we start adding more sand, it's going to take longer until time remaining runs out, because time remaining is going to be counting down. But very important to keep that in mind. This way, it's not like it is a steady, predictable timer that just says every half a second, move. move, move. This time it can change because we have the ability to slow down. Okay, I just want to throw that out there real quick. So we will be dealing with a very simple timing system once again, but this time around the timing system is just a little bit more advanced than when we were working with the timing system back in Precision, right?
Right, it's that we're going to be modifying the timer in essence. As we use it to control the speed of the bike.
Exactly. Okay, so now we're about to get ready to code. I think we've given a pretty decent overview of, I guess you could say, the meat and potatoes of what we're going to be putting together. Let's go ahead and bring up a new layer real quick and talk about what videos we're about to be looking at. So let's go ahead and just hide that. So we've got 4 different videos that we're going to look at. So video number 1, what are we going to be focusing in the first real video where we begin coding? Well, it's going to be basic setup, right? We all know this. We've seen it a million times.
Need a project. We probably need some texture assets.
You got
all
it.
of the basic building blocks.
And then once we get all that in place, then we'll move into things like classes. We'll put in all of our basic fields to begin with, at least the ones in the game class. We'll handle some initialization stuff. We'll load our graphics. And let's see. Actors list. Ooh. What kind of classes are we going to be using in this? Well, we're going to have actor. So obviously we're going to have actors. We're going to have a bike class. And we're going to have a wall class. Okay, simple as that. And what is bike going to be? Bike is going to actually derive or be an extension of actor. So it's going to inherit from actor. Wall is going to be a static class. It's going to be all by himself. He is not going to inherit from actor. So when we are to loop through a list of actors, we're going to be looping through a list of bikes. Now, of course, you have the option of going in there and putting in cool power-ups and stuff like that. And then those power-ups, of course, also are an extension actor and get thrown into the actors list and can have all sorts of cool functionality. But once again, we're focusing on very specific engine for handling these bikes cruising around. So keep that in mind, okay? So anyways, that's what we're looking at. So bike and actors, heavily related, and wall. All right, once we get all this done, we will simply end off video 1 with background drawing. So no bikes yet, no movement, no input control, nothing like that. So that'll then push us into the wonderful world of video number 2. In video number 2, we're going to implement the bike class. So I'll just write down bike class. In this, we're going to get basic movement in place, and we'll go ahead. So I'll just go ahead and put basic movement. Ooh, what do I mean by basic movement? That is something I wouldn't mind taking just a second and mentioning before we move on. So don't let me forget, Logan.
Sure.
So basic movement, and we're going to take braking. We're going to go ahead and get the brakes in place too. And there will be no walls. So I'll just go ahead and write no walls as a quick reminder. No walls with an S. There we go. So by the end of video 2, Logan will be able to grab a controller, I'll be able to grab a controller, and we'll be able to cruise around the screen. But when we cruise around the screen, it's going to be a very blocky motion. So you don't have to remind me, I actually remembered. And here's what I mean by that very blocky motion. Notice we've taken our screen, we've divided it up into a grid, and we're only able to move every X amount of time, a time based on that move interval and the time remaining counting down to 0. So if it's every half a second that we were to move, well, if you looked real carefully, you might see a little bit of a jitter. But what happens if we start slowing down to where we move every 1 second or every 1.2 seconds as we're approaching a stopped state where the bike is just sitting there? So we're getting slower and slower. Well, if we were to only move 1 grid unit every second, wouldn't it be very noticeable that it would be chop, chop, chop?
Right, that's going to be noticeable because the grid blocks may be somewhat large in size. If a grid block was 8 pixels across, it would be very easy to notice an 8-pixel jump as the bike moved.
That's right, because you'll notice I drew these big blocks there. What I did not draw was, if we were doing something like a 640 by 480, let's say that was our screen size, and let's say that was also our grid size, then what would we have? Well, our grid size would be represented with 640 dots all the way across, real small. things would look a little bit smoother here, right? But we're not dealing with that. We're going to be dealing with, in fact, I think it's 8 pixels we're actually going to be using for our block size in this particular case. So yeah, with it being 8 pixels, you're going to get a jump, a noticeable jump. So it's going to be like a stutter. So we need to smooth that out. And so at the very end of this engine that we're putting together, we're going to show you how to get the interpolation into place to make a nice smooth motion for the bike so that you never get that jumbled up feel. So when I say basic movement, when I'm talking about the videos that we're putting together here, we're not going to have any smooth interpolation in place. From there, we're going to move on over into video 3. In video 3, what we're going to do is implement the wall class. Now, that does not mean we're suddenly going to have the bikes kicking out laser walls behind them. Nope, unfortunately not. What we're going to have is the system set up to, well, store wall segments into this array, into this grid, if you will. So the idea is to get the wall class implemented, and then what we'll do at the end is we'll just hard code. We'll put some data ourselves into that array. So we'll hard code a wall demo. We may just say, all right, let's do something like line, line, one of those turns, line, line, turn, something like that, just so that we see a nice, smooth-looking wall like that. But it's completely predictable because we told it exactly where on the grid to put these lines, and then when we ran the application, boom, there was our little wall. Okay. Again, no collisions. We can still control the bikes. Everything that was put into video 2 still there. But with video 4, it all comes together. In video 4, we're going to have the bikes draw the walls, not us. So we'll get rid of our little demo wall. In fact, let me not even say draw. Let me just say bike emits wall. Okay. And we'll go ahead and get wall collision into place. So our collision detection system will be there. And then finally, we'll go ahead and wrap things up with smooth interpolation. So that our bikes move nice and smoothly. And with that, that'll basically wrap everything up. Anything you want to add to all this, Logan?
Just to point out that the collision system is going to be very simplistic in this version of the engine. It's only going to be I guess you could say, an on-off detection system. The outer walls count as the same thing as the emitted walls, and no information is passed as to who collided with what.
Right.
Now, the way it's set up, the information could be passed. So
easily.
All of the methods could be modified very slightly to accommodate any information you would want to know at any point. But we're leaving it very simple since this was to get the engine, the line-based, the line-drawing engine, the grid engine itself.
That's right.
Up and running. So the collisions will be simple, but they should be easily expandable.
Oh, it's all about the educational experience here.
Also, where we could point this out, that our demo version is only going to have 2 players. But it's going to be designed in such a way that adding more players should be very simple.
Very easy, yeah. Like I said, it's all about the educational experience as opposed to us just walking through, showing you every single line in a fully functional game. We've already done that a bunch of times. It's really nice getting to see the students in the XNA class come up with their own visions of the game. It's just really nice seeing that take place now. So, with that, I can't wait to see what kind of LaserBikes games come out of this. So with that is going to wrap up this quick overview, and it is time for us to jump right into the coding phase of video 1, and as we do, we'll just walk our way through the code and explain what's taking place. So let's get started.